Hello and welcome to this calculus video. Today we will be talking about more rules for computing derivatives.
Math 112.
So far, we can differentiate polynomials and the exponential function, and arithmetical combinations of these functions. Today we are going to broaden what functions we can differentiate to include trig functions as well as the composition of two functions. Let's try to compute the derivative of the sine function. By definition, it is the limit of the difference quotient. We can use the sum angle formula to expand the sine x plus h and gather the terms. We end up with a few different limits, and the two that remain look tough to solve. Instead of formally computing these limits, let's take a look at what Desmos draws. We see here the graph of the sine function with the tangent line to a point all in orange. As we move the point of tangency to the right, Desmos plots the slope of the tangent lines in purple. This graph may look familiar. Indeed, it is cosine of x. To reiterate, the derivative of sine x is cosine. We might hope the derivative of cosine is sine. This is almost true. It is in fact negative sine. Now we know the derivatives of sine and cosine, so we can find the derivatives of the other trig functions using the quotient rule. For instance, the derivative of tan x can be found by writing tan x equals sine x over cosine x and applying the quotient rule. Notice that in the numerator we get a sine squared x plus cosine squared x, which is 1. You can do the other trig functions, cotangent secant and cosecant, in a similar way. Now we move on to how to differentiate a composition of functions. The rule that tells us how to do this is called the chain rule. It turns out that the derivative of f of g of x is f prime of g of x times g prime of x. We can use this rule to compute derivatives of a very large class of functions. For example, let's differentiate the function square root of x squared plus 1. This function is the composition of the square root function on the outside and the polynomial function x squared plus 1 on the inside. We can differentiate these separately using the rules we already know, and then recombine those derivatives to get the derivative of the whole. It is important to remember to plug the inside function into the derivative of the outside function. It is f prime of g of x, not f prime of x, in our chain rule equation. We can use the chain rule to differentiate all exponential functions, not just the natural exponential. We use the fact that e to the x and ln of x are inverse functions and the laws of logarithms to rewrite b to the x as the composition of the function e to the x and the function x times ln of b. We can differentiate this using the chain rule, and then use the same algebra trick in reverse to find the derivative of b to the x is ln of b times b to the x. Note that this rule does not contradict our rule for e to the x, because ln of e is 1. That's all for now, folks. Today we found the derivative of sine x is cosine of x, and the derivative of cosine of x is negative sine of x, and we noted we could use this with the quotient rule to differentiate all the 6 basic trig functions. We also stated the chain rule that lets us differentiate a composition of functions and use this to compute the derivative of a general exponential function.
Math 112.